So welcome on this very sunny Saturday afternoon. If you have a statistics course and you need to calculate critical values, let me show you how easy this is to do with spreadsheet software. I'm just going to use Google Sheets and we're going to use a normal distribution, and I'll show you, irrespective of how you state your alternative hypothesis, how to calculate those critical values. So I've opened a Google Sheet and we're going to look at calculating these critical values for the Z distribution. Now, as I've mentioned, we do need to know what our level of significance is. So put it in a cell. I've put it right there, 0.05. Let's go for that. We also need to know whether our alternative hypothesis is two-tailed, or is it one-tailed lower or one-tailed towards the upper tail. So you've got to know these two things. So let's think about the parameter that we require for this two-tailed alternative hypothesis and a significance value of 0.05. So what we want that critical value, and usually we take the positive version of it, so it's going to be in the upper tail. Now think about it, we want 5% in total. That's our level of significance, meaning we want 2.5% of the area under the curve. That's that probability density function curve. We want 2.5% in each tail, which means if we go all the way across from negative infinity all the way across to that upper tail, so that we eventually are only left with 2.5% in the upper tail, so towards positive infinity, that means we are covering 97.5% of that area under the curve. So think about it. We need to be, for our parameter, and we're going to put it in the cell here, equals 1 minus alpha divided by 2. And that's going to give us that 0.975. We are 97.5% of the area under the curve must be to the left of this critical value, so that we're only left with 2.5% of the area under the curve towards the right. When we're talking about a one-tailed lower, meaning we're putting all that 5%, our region of rejection contains the least probable values in the lower tail. So we want all of that in the lower tail. So I'm going to say equals, and it's just going to be this 0.05. And if we want a lower one-tailed upper, of course, that's going to be 1 minus this alpha value. So I'm just going to say equal 1 minus, and I'm going to click on that 0.05. And that gives me the 0.95. So these are the parameters that we are going to require for our critical value. So let's look at the equation. That's going to be equals norm. You can come all the way down there. We see norm.s.inv. I can click on that. And we see we just need to have this parameter. So it's equals norm.s.inv, open parentheses. I can click on this 0.975, or you can just fill in 0.975. I close my parentheses, I hit enter, and I see there is my critical value. Two-tailed alternative hypothesis, 0.05 for my level of significance, and this is a standard normal distribution, meaning my critical value is going to be 1.96, as you can see there. Let's have a look at what this is going to be if my critical value needs to be in the lower tail, such that I'm looking at that least probable 5% of Z values in the lower tail. So that's going to equal norm .s.inv. I'm going to select that one, and what I want as my parameter, indeed I want this value as my parameter. You can just type in 0.05, and there we go, it's at negative 1.6448. And if we want this in the upper tail, that's going to equal norm.s.inv, and indeed we want that value here. See, 6 in my instance, and I get the positive version of that is 1.64485. So now I can just change this value right here. I can make this 0.01, and you can see what the critical values are going to be now. That's at 2.57, negative 2.3, positive 2.3. And then look at these parameters. Remember, for this one, it's always going to be 1 minus alpha divided by 2. This one's going to be alpha. This one's going to be 1 minus alpha.